In this demonstration, we will show how the NX Durability Wizard will be used to evaluate the fatigue life of a knuckle part under various loading conditions and represented by a static solution. NX Nastran will be used to determine the stresses and strains in the part. Fatigue life will be computed using the high cycle stress approach. Let's begin by going to the FEM level to examine the material properties assigned to our mesh, since durability analysis requires a definition of unique fatigue properties. In the Manton material description, we notice the Strength tab, which contains the yield and ultimate strength properties that are used to evaluate the static strength safety factors and margins of safety. In the Durability Formability tab, we notice the fatigue strength and fatigue ductility exponents and coefficients, which are used for fatigue computation. You'll also notice cyclic parameters, which are used to convert between stress cycles and strain cycles while computing fatigue life and damage. This type of data, along with other simulation-specific information such as CAE libraries, requirements, and workflow processes, could be saved and reused in the Team Center for Simulation environment. This data management tool allows easy sharing of data between multiple teams, sites, and suppliers. Let's return to the sim level to examine and solve the solution. In the Simulation Navigator, Static Solution 101 will be used to illustrate the Durability Wizard's capability to create and analyze a cyclic event. Let's quickly solve this Static Solution 101 and examine the results. We notice that the maximum stress results are significantly lower than the yield strength of the material. Therefore, a stress life approach will be used to evaluate the durability of this part. We can now proceed to setting up the durability solution process with the Durability Wizard. Go to Tools, Durability Wizard to add a durability item in the Simulation Navigator. As we set up the solution process with the wizard, you will notice the left-hand side window will become populated with the durability setup information that you could later edit. Static Solution 1 has been detected by the wizard. We will create an excitation that will use the loads defined in the static solution. To define the cyclic loading pattern, you can enter the number of cycles, a scaling factor, and a loading pattern. You have the option to apply this loading with or without load reversal. Next, the Durability Wizard prompts you to enter the durability parameters in the following tabs. We will use these tabs to set up our durability parameters, which are appropriate for this case. On the Stress Safety Factor tab, we'll choose a stress criterion such as yield. On the Fatigue Safety Factor tab, we'll define a design life criterion. Notice the fatigue strength factor. This factor is used to correct for the effect of maximum alternating stress. It takes into account certain relative characteristics such as the type of surface finish and surface treatment. And third, on the Fatigue Life tab, we can define a fatigue life criterion. In this case, it will be the high cycle or stress life. Notice that you also have other life criterion choices such as low cycle or strain life. Clicking Next at this point will launch the durability solution. Once the solution is complete, 3 result types are displayed and are accessible through the wizard. You can click on either of their icons to display these results. And note that once we finish with the wizard and exit the dialog, the results will also become accessible from the Post-Processing Navigator. This permits access to the full suite of NX post-processing tools. Another handy option is to export the summary data to an Excel spreadsheet for further study. Note that once we finish with the wizard, the durability solution process we just defined becomes accessible from the Simulation Navigator and is fully integrated in the UI. This means that you can examine all your solution sets and results in a single environment. Whether they be fatigue, static, vibration, or even thermal or fluid flow analyses, NX Simulation also provides an integrated environment for your multi-physics and multidiscipline analysis needs. If required, we can edit the durability static event by using the wizard. A design change, however, at the base of the knuckle could help increase the fatigue life further. Therefore, we may want to create a what-if scenario and make a design change on the knuckle. The seamless integration of the simulation and design environments in NX allows us to easily go back to our CAD to make design changes and then jump back to our simulation environment to rerun the analysis. We will add a fillet at the base of the extrusion in the hopes of increasing the fatigue resistance of the part. Once we have done this design change, we can go back to the FEM level. We notice that the design change has been detected and we are prompted to update the mesh, and this is done at the click of an icon. Proceeding back to the sim level, notice that all our static and durability solution setup parameters have been conserved and applied to the new geometry, so we can quickly rerun this new case. By observing the results of our new design, we can see that the fillet has indeed improved the fatigue resistance of our part. This has illustrated a major advantage of NX, which is the seamless integration of the simulation and design environments. It allows us to efficiently create what-if scenarios without ever programs or leaving the NX interface. This concludes the demonstration of the Durability Wizard. Thank you for joining us.